Hey guys, it's Mary and welcome back to Study Journey. Welcome back to another ACT video. It's been a while since I've done one, but I've gotten some requests to do how to get a 36 on the ACT math. And this is one of my best subjects, so I thought it would be good to share some tips with you guys. I do have a 36 on the ACT math, and so I thought I'd summarize basically everything that you need to know for the ACT. Okay, so I've separated this video into a few sections. So first of all, I'm just going to go over some basic tips and everything you need to know for the ACT math. And then I'm going to go into detail about specific concepts. So it's separated into the basic general tips, must know concepts about triangles, and then we're going to go into trig concepts, matrices, exponent rules and log rules, and then polynomials, and then finally volume and area. I'm sure there's a lot of different concepts that you need to know for the ACT math, but I just thought we would go through some of the stuff that you may not know based on what you get taught in school. And I have a lot of example problems in here, so these are some must-know problems that you'll probably see just with different numbers on the test. So one of the best ways to actually get better on the ACT, especially ACT math, is to just do a lot of practice problems and then go over the ones you missed and then find why you missed it and then work on those concepts. So for all of the problems in this video, I've actually been using the McGraw-Hill 10 ACT practice sets. I will link that down below. It is literally a free PDF online. You can just download it and just do a bunch of practice sets. There's 10 practice sets on there and I think it's really, really good. You can also get them from the ACT website and all of that, but I don't know how many they have. So if you ever want extra practice, this is a really good resource to use. But all the problems on here are either from the math section from practice test 6 or practice test 9. So if you guys want to do those practice tests before watching the rest of this video so I can explain some of those problems, then feel free to do that. And if you haven't watched my tips for the ACT the night before video, make sure to go check that out. That was from a few years ago. I'll link that down below. And then there was also another video I did where I talked about basically all sections of the ACT, and if you haven't watched that, you can also check that out. I think it's pretty useful. That was how to study for the ACT, if you have a long time. So I hope this video is helpful, and let's get into the video. Okay, so I do have my little sheet right here where I'm reading off of it because I wanted to plan everything out before I get started. But first of all, some basic things you need to know about the ACT math. So first of all, it's 60 minutes, 60 questions. If you divide it evenly, that's 1 minute per question, but the thing is, the questions get harder as they go. So the beginning questions shouldn't take you 1 minute, and then the questions at the end might take you longer than a minute. Okay, so one thing I do suggest is you take Algebra 3. That will probably get you the best ACT score because you do need to know trig concepts on here, and you don't usually get taught that in previous classes. I don't know how different schools work, but maybe you do get taught it, and we just don't get taught it in our school. But for our school at least, we get taught trig concepts and Algebra 3, so sine, cosine, tangent, and all of that. But you only really need to know the basic concepts, so even if you haven't taken Algebra 3, you can literally self-study it because it's super easy. But yeah. So going on to some basic tips, first of all is mark keywords. This is super important because the problem has everything basically written out for you. You just have to translate it into math. So you don't want to get something wrong if it's greater than, less than, how many times greater than, if it's the smallest to greatest or greatest to smallest. That's a really big thing to remember. And then if it's increase or decrease, you don't want to mess that up. And then also units. So if the problem has something in kilometers and you're trying to find the answer in meters, then make sure you know to convert it back, or you know which units you are in. And then oftentimes if you mark keywords, you know how to solve the problem because all you have to do is basically translate it. And if you don't know how to do that, here is another tip that is really good, and I always tell my sister to use it when she doesn't know how to do a problem, which basically if they give you a formula and answers or the opposite, all you have to do is plug it into the answers. So if the answers are numbers and you're given a formula, or the answers are formulas and you're given a number, all you have to do is plug it into the formula, and which one works should be the right answer. For most of these problems, all you have to do is plug it in and then check. This is for any of those equation problems, and you'll know when you get on the test. So if you see numbers and equations, try plugging it in if it's asking you to solve for it. Okay, and then also another big tip is I don't think most people know because sometimes on tests at school they don't do this, But if they give you a diagram, so if the test gives you a diagram, so if it's like a circle, a triangle, anything like that, use it, because most of the times it is an accurate diagram. So if it looks like a right triangle, it probably is. If the sides look equal, it probably is an equilateral triangle, like that stuff. So when they give you a diagram, make sure to look at it and try to use it to solve the problem, because sometimes even if you just like guess the answer and you measure it with your fingers, so it's like, what is this distance? And then they tell you like a distance of a small one, then you can literally use your fingers and try to find it, and you'll probably get like an answer close to the correct one. Alright, and then going off what I just talked about like in the beginning, translate everything to math. So if it says of, to multiply, you're putting something in addition to something, you're adding more to it. If you're taking away, you're subtracting. Basically, if they give you a word problem, go through each step, and then if it says like, they give you an initial problem, and then you add more to it. So write this all down, just translate everything to math, to symbols, and then try putting it all together, because it might be overwhelming in the beginning if there's like just a lot of concepts in the problem, or if it's a really long word problem. Okay, and another one, it's not really a tip, but it's something to make sure to know and remember, is to make sure your calculator is allowed. So calculators are allowed in the ACT math section, but it's just like accepted calculators. So you can use like the TI-84, scientific, etc., but you can't use graphing calculators like the TI-89. Before you take the test, make sure to check that you have the right calculator, and they have like the accepted calculators on their website. And also just like go through the rules, and they usually send out an email of what you bring before taking the ACT. Well, that's basically it for the basic general section. So now we're going to move to the must-know concepts, and also I'm going to provide a lot of example problems in these sections. For the first part, we're going to be talking about triangles. Alright, so the first thing we are going to talk about triangles is the Pythagorean theorem, which is basically saying a squared plus b squared equals c squared, and this is talking about the two legs of the triangle and then the hypotenuse. So for every right triangle, the side squared plus the other side squared is equal to the hypotenuse squared. This is really important to remember, because if it gives you a right triangle and it's asking you for the length of one of the sides, then you can probably find it by using the Pythagorean theorem. Another thing to remember is, because like this is a Pythagorean theorem and it's like a theorem, something else that goes with it is Pythagorean triplets. So what this is that like if they give you the sides 3, 4, and 5 on a triangle, then it is going to be a right triangle, because 3 squared plus 4 squared equals 5 squared. So you can also like basically do the opposite way. If they give you the lengths of each side of the triangle, you can determine whether or not it is a right triangle. Okay, but some Pythagorean triplets to remember are 3, 4, 5, and then 5, 12, 13. So if the side lengths have the proportion of 3 to 4 to 5, or 5 to 12 to 13, then you know it is a right triangle. And okay, so let's try the first problem. So let's try number 15 from practice test number 6. It says that the circle shown below has a radius of 5 meters, and the length of chord XY is 8 meters. If C marks the center of the circle, what is the length in meters of segment CZ? So as we can see, they're asking you to find this segment right here, and it shows you that this is a 90-degree angle. So if it says that the radius is 5 meters, then that means this from the center to any part of the circle is going to be 5 meters. So let's connect C and Z, for example. So that would be 5 meters. And then it says that the chord of XY is 8 meters. So all of this together is 8 meters. And it is asking you what this is. So as we can see, this right here, XZC, forms a right triangle. And if right here this is a right angle, then this means that XZ and ZY are the same. So we know that XZ would be 4 meters. And so if the hypotenuse XC is 5 meters, XZ is 4 meters, then what is CZ? Well, just by knowing the Pythagorean triplets, we know that CZ would be 3 meters. But if we were to do it the long way, then you could use a Pythagorean theorem, which states that a squared plus b squared equals c squared, and then a is the length of CZ, so CZ squared plus b squared, let's say that is b, and then this is c, then it would be plus 4 squared equals 5 squared, and then if we get 25 equals 16, and then CZ squared, then CZ would be the square root of 9, which is equal to 3. So either way, you would get 3 meters and the answer will be B. However, notice how if we know your Pythagorean triplets, then it will be much easier. Now, let's try the next problem. So this is question number 36, also from practice test 6. It says that sides A, B, B, C, C, D, and DA of square ABCD are broken up by points W, X, Y, Z, as shown below. If AB is 6 inches long, what is the area in square inches of the shaded region? So it gives you that right here ABCD is a square. And so these are all going to be 90-degree angles. Notice how I'm going step by step from what the problem gives us and then marking it or translating it into math or picture terms. Okay, and then it says that AB is 6 inches long. And since this is a square, if we know that AB is 6 inches long, we also know that BC, CD, and DA are also all 6 inches long. And then so it is asking you what is the area of the shaded region. So square ZWXY. We know that if AB is 6 inches long, then AW plus WB is also going to be 6 inches long. And notice right here, it gives you that ZD is X and then DY is 2X. So basically this is saying this side DZ compared to DY, DY is twice as much as DZ. So using this, we know that since ABCD is a square, and since these are all right triangles, that these triangles right here are all similar triangles. Meaning if DZ is X, then YC must also be X. So basically this is saying DC is equal to 3X, and this, remember, is 6 inches. So X is equal to 2 inches. So now that we know that, let me enlarge this triangle right here. So that triangle was DYZ, and we know that this is a right triangle, and we said that X is 2 inches, and then 2X would be 4 inches. And then we're trying to find this area right here, and notice that these are the edges of the triangle. So if you can find one edge, then you can find the area of the square. So let's just find YZ. So what is this? So we can use the Pythagorean theorem because this is a right triangle, and we can say a squared plus b squared equals c squared. And then we know the a would be, for example, 2 inches. So 2 squared plus 4 squared, and then we're trying to find c, which is the hypotenuse. So 4 plus 16 is equal to c squared, and that's 20 equals c squared. So c is equal to the square root of 20. So zy is equal to the square root of 20. And if you're trying to find the area of the shaded region, and this is a square, it is just going to be the side squared. So it's going to be zy squared, or the square root of 20 squared. And then the square root and then the squared cancel out, so it's just going to be 20. So the answer is H, 20. Okay, and then another thing to remember is the specific types of triangles. So like the two that you should probably remember are the 30, 60, 90 triangle and then the 45, 45, 90 triangle. So what this means is if the angles are 30 degrees, 60 degrees, and 90 degrees, then you know that the smallest side is going to be like a number. So I'm going to say X. And then the hypotenuse will be 2X. So the hypotenuse is 2 times the smallest leg of the triangle, and then the other one will be the square root of 3x, and this can apply to any numbers as long as it follows the 30, 60, 90 degrees. Another one is the 45, 45, 90. So because 2 of the angles are the same and it is a 90-degree triangle, then we know that it is an isosceles triangle. So the 2 legs are the same, and then the hypotenuse is square root of 2 of that leg. And just make sure you know these, because if it gives you one side of like the leg, it is so much easier to just multiply it by square root of 2 and to find the hypotenuse, or multiply by 2 if it's a 30, 60, 90 to find the hypotenuse, than to go through like all the steps of the Pythagorean theorem. These are basically just shortcuts of the Pythagorean theorem. You can find all of these using the Pythagorean theorem, but since the ACT is short and you don't have a lot of time to work out basically everything, then it is so much easier if you already know these concepts and you can just use it instead of trying to solve it and figure it out. What an isosceles triangle is if the two legs are the same or if the two angles are the same, like of a triangle. So of a triangle, if any of the two legs are the same in length, then you know it is an isosceles triangle, and also the two angles that correspond with those two legs are also equal. If in a triangle two angles are the same, then you know that two legs are also the same. It is an isosceles triangle and vice versa. Okay, another type of triangle that you'll probably see a lot on the ACT is if they give you a triangle and then there is a line and it is like parallel to the base, and it is asking like what a leg is or how long or the area of the triangle. If there is a line separating the triangle and it is parallel to the base, then that means that the small triangle and the original triangle are actually similar triangles. Each angle is the same and then their sides are proportional to each other. So here is our example problem. This says that if the figure below, line AB, is parallel to the base of the triangle and creates a smaller triangle inside of the original triangle, if the length of the segments are as shown and the smaller triangle has an area of 8 centimeters squared, what is the area in centimeters of the original triangle? Okay, so let me label this triangle so I can talk about it more easily. Since they already used A and B, I'm going to say that this is going to be C, D, and E. And then I'm going to label these intersections right here as F and G. So now that we have this, first of all, it tells us that DF is equal to 4 centimeters and then FC is equal to 12 centimeters. So it is saying that the small triangle in the middle right here, FDG, it has an area of 8 centimeters squared. And so it is asking you what is the area of triangle CDE. So that is what we're trying to find right here. So how do we find this? Well, since it already says that AB is parallel to CE right here, then we know that these are going to be similar triangles. So triangle FDG is similar to triangle CDE. What it means if they are similar is that their angles are the same and then their sides are also comparable. So what this means is that angle DCE right here is equal to angle DFG. And then the same for angle DGF right here, and then angle DEC right here. So these two are the same, and then these two are the same on the left. So since it is asking you the area, then we know that it is a specific amount larger than the a triangle that they gave us, which is a smaller one. So how many times bigger is the real question. So since we know that DF is equal to 4, and then FC is equal to 12, then we know that DC right here, this in total is 12 plus 4, which is 16 centimeters. So CD is equal to 16 centimeters. So we know that triangle CDE is about 16 over 4 times greater than the smaller triangle. This total length right here is 16, and then this small length right here is 4. So basically the area will also be 16 divided by 4 times larger. And 16 divided by 4 is 4. So the area of CDE should be 4 times as large as the area of triangle FDG. So the area of triangle CDE is going to be 4 times 8 centimeters squared, which is equal to 32 centimeters squared. And that is going to be C. Okay, something else with similar triangles. If two triangles are similar, then their legs are proportional to each other in length, and also the angles are the same. So here are 2 example problems for that. Okay, let's look at another one. So it says that triangle ABC is similar to triangle XYZ, and that AB is 5 inches long, BC is 8 inches long, and AC is 3 inches long. If the longest side of XYZ is 20 inches long, what is the perimeter in inches of triangle XYZ? So let's draw a diagram. So here's triangle ABC and XYZ. It says that AB is 5 inches long, BC is 8 inches long, and then AC is 3 inches long. I try to draw it so at least like it looks like what the numbers are, so it's not like the 3 inches is the longest one. So it says that in XYZ 20 inches is the longest side. So that would be YZ. So this is going to be 20 inches long. And so it is asking what the parameter of XYZ is. So we have to find out what XZ and XY are. Well, we know right here that ABC and XYZ are similar triangles. If CB versus ZY is equal to 8 over 20, then that means AC over XZ should also equal 8 over 20. And then so should AB over XY, because these are similar. But what is it in terms of the fact that if AC is equal to 3 inches, then what will XZ be? And this has to be equal to 8 over 20. So what number right here placed can make this equation true? Well, we can cross multiply, and it makes 8x equals to 3 times 20, and then x would be 3 times 20 divided by 8. And then if you use your calculator, 8 is equal to 7.5. If AC is 3 inches, then XZ would be 7.5 inches. And then if AB is over X over Y is also equal to 8 over 20, what is this when AB equals 5 inches? What is XY? So I'm going to put Y as a variable, and then cross multiply. 8y is equal to 5 times 20. Y is equal to 5 times 20 divided by 8. And that gives you 12.5 inches. So XY is 12.5 inches. So the perimeter of triangle XYZ will be 7.5 plus 12.5 plus 20, which gives us 40 inches. And then that would be answer C. So now let's look at a problem from practice test 9. This is question number 8, and it says that in the figure below, x and y lie on the sides of ABC, and xy is parallel to AB. What is the measure of angle C? So try to find this angle right here, and if xy and AB are parallel, then we know that triangle XCY is similar to triangle ACB. So the angles of these two triangles should be the same, which means if angle CXY is equal to 40 degrees, then angle CAB right here should also equal 40 degrees. So looking at our big triangle right here, if we know two of these angles, then we can find out the third angle, because these three angles added together should be 180 degrees. So 40 degrees plus 80 degrees plus this angle C should equal 180 degrees. So 120 plus angle C should be 180 degrees. So angle C should be 60 degrees. And that would be answer J. Okay, and then now we're going to talk about perpendicular line of a triangle and like bisection and all of that. If there is a perpendicular line that bisects one leg of the triangle, then it is an isosceles triangle, and then the two legs corresponding to it are equal. So this like goes multiple ways. So like if there is a line that bisects a triangle and then it is an isosceles triangle, then you know that the line is perpendicular. So you can have multiple ways to figure out this one thing from this theorem by itself. Okay, so this is also a pretty important thing to know, because if you don't know, you probably won't know how to solve some problems that use this method. So here's another example problem for this. Bisect. So we're trying to use what we just talked about for the isosceles triangles. So let's look at this. It says in the figure below, AC is the diameter of a circle. B is a point on the circle. AB is congruent to BC, and D is the midpoint of AC. What is the degree measure of angle ABD? Okay, so let's do it line by line. So it says that AC is the diameter of a circle, so we know that D is the center, and then AC is what is the distance across from the circle from the middle. And it says B is a point on the circle, and AB is congruent to BC. The word congruent means that they are equal. So it is saying that AB is equal to BC. And these lines are just saying that these two lines are equal. And then it says that D is the midpoint of AC. So if it is the midpoint, then that means AD is equal to DC. Since it is in the middle, then it splits AC in half. So now that we know that AB and BC are equal, and then AD and DC are equal, then according to what we just talked about, BD must also be perpendicular to AC. And so now it is asking you the degree measure of angle ABD, which is this angle right here. But since we know that AB and BC are equal, then we know that in an isosceles triangle, the angles are also equal. So angle BAD is also equal to angle BCA. And so since these two angles are equal, then we have that. And remember when it says that AC is a diameter? Well, diameter is equal to 2 times the radius. So basically DC and AD are the two radius of the triangle. And we know that the radius is from the center to any point on the edge of the circle. So what that means is that BD is also the radius. So not only is AD right here a radius, DC right here is a radius, but also BD is also a radius. And since all radius on a triangle are the same, then that means AD right here is also equal to BD, which is also equal to CD. See how this information, like this small piece of information, tells us so much? So yeah, so now that we know that these two angles are equal, then look, this is basically another triangle right here, an isosceles triangle, because these two sides are equal, and we're trying to find this angle right here. Well, we know that this angle is equal to this angle down here. So what we know is that this angle is also equal to this angle down here, and then this angle is also equal. So basically, right now, looking at the big triangle ABC, we know that all of the angle measures within it is going to be 180 degrees total. Let's say this angle be theta. Then this angle is also theta, and so is this one, and so is this one. So 4 thetas is equal to 180 degrees. So what is the degree of one angle? Well, that is going to be 180 degrees divided by 4, and that is going to be 45 degrees. Or we can also look at the fact that this is a right triangle right here. Well, if this is a right triangle and it has 2 angles that are the same, well, these 2 angles have to add up to 90, and since they're the same, they are going to be 45 degrees each. Either way, the answer is going to be B. Alright, now we're going to move on to trig concepts. Trig concepts, like I said, is for us is taught in Algebra 3, and this is a pretty large portion of the ACT actually. ACT math doesn't go to calculus, so there's no calculus concepts on here at all. But there are trig concepts, and it's usually like really basic trig, so as long as you know what sine, cosine, tangent, and all of that are, then you should be fine. In a triangle, the sine of an angle would be the opposite over the hypotenuse. So in this case, it would be A over C. If it was cosine, then it would be adjacent to the angle and then over the hypotenuse. In this case, it would be B over C, and then tangent is opposite over adjacent, and that would be A over B. And then cosecant, secant, and cotangent are basically like the inverses of sine, cosine, and tangent. So cosecant is 1 over sine, so in this case, it would be C over A. Secant is 1 over cosine, and in this case, it would be C over B. And then cotangent is opposite of tangent, so it is adjacent over opposite. And so in this case, it would be B over A. And the applications of these are usually pretty straightforward, or they're asking you how to like cancel out stuff. So they want you to know that tangent is actually sine over cosine, and then cotangent is cosine over sine, and some of these things that you just need to know. You can search up like basic trig concepts, and like you should be able to learn all these pretty quickly if you don't already know them. So here are some example problems for those. Question number 32 from practice test number 6 says that if sine A is equal to 3 over 5, then which of the following could be tangent of A? So let's draw a triangle, since we know that trigonometry deals with right triangles. So I'm going to draw a triangle right here, and I'm going to label it A, B, and C, where B is the right triangle. So it says that sine of A is equal to 3 over 5. So that means sine of this angle right here is the opposite over hypotenuse. So that is 3 over 5. And then tangent, we know, is opposite over adjacent. So we just have to know what this adjacent AB is. And as we know by our Pythagorean triplets, we know that AB would be 4, and we can always use Pythagorean theorem to find that if we don't know that. Tangent of A, where A is theta, is going to be the opposite over adjacent, which is 3/4. So the answer to this would be G, 3 over 4. Okay, so question number 56 says that for values of x where sine of x, cosine of x, and tangent of x are all defined, what is cosine of x over tangent of x times sine of x? So let's rewrite this. So we know that the top is cosine of x, but then tangent x we know is sine of x over cosine of x, and then times sine of x, because we know that this is the same as tangent x. So now let's rewrite this again, where it is going to be cosine of x over sine of x squared over cosine of x. If you're dividing it 2 times, then that is equal to multiply it. So that would be cosine squared x over sine squared of x. And so our answer would be F. Basically, we were just simplifying the equation here. Okay, in practice test 9, question number 21 states that in the right triangle shown below, which of the following statements is true about angle x, which is this angle right here. And it is asking you in terms of like cosine, sine, tangent, etc. So let's see what cosine of x is. So cosine of x, we know it is adjacent over hypotenuse. And so that would be the adjacent right here, which is 5, over the hypotenuse, which is 13. So cosine should be 5 over 13. Well, we know that this would be false, and this would be false. So now, what is sine of x? Well, sine of x is equal to the opposite over hypotenuse, so it will be 12 over 13. And here is the answer right here, and we know that this is false. But we can check to make sure. So what is tangent of x? Well, tangent of x we know is opposite over adjacent, and that would be 12 over 5. And that is not 5 over 12, so our answer is B. Question 38 states that the hypotenuse of right triangle ABC shown below is 16 inches long. The sine of angle A is 3 over 5. About how many inches long is BC? So first it states that ABC is a right triangle. So the right angle right here will be B. And then it states that the hypotenuse is 16 inches long. The hypotenuse would be AC, and so this is 16 inches long. And it states that the sine of angle A is 3 over 5. The sine of an angle is going to be the opposite over hypotenuse. And in this case, it is 3 over 5. So it is asking how many inches long is BC, and this is also the same as the opposite. So what we're trying to find right here is this measurement right here. So let's let that be x. We know the hypotenuse is 16 inches, and this is equal to the proportion of 3 over 5. Now let's cross multiply. 5x is equal to 3 times 16, so x is equal to 3 times 16 over 5. And that would be 9.6. So BC would be about 9.6 long. Okay, so moving on to matrices. This is a concept that is actually, like, for us, never taught in school. Like, we never learned what matrices are. And I don't know for a lot of you guys, but like before the ACT, I actually like never even knew what a matrix was. So for the ACT, they really only have like probably 1 to 2 problems on each test about matrix. And also it's really easy to solve as long as you know it, because they only test like the very bare minimum, like addition and then multiplication, like very basic multiplication too. So for matrix, like this is what it looks like. For addition, you literally just add over. For subtraction, you just subtract over, so like the corresponding ones, and then you end up with a matrix that has like the sum or the difference of those two, and it is literally just each number from the corresponding places subtracted or added together. And then if it's multiplication, then you're also just multiplying over it. It's usually like a one column times 1 row matrix, and those are usually the ones that do multiplication. So here's an example for that one. Okay, so let's look at a matrices problem. So this is from practice test 9, and this is question number 45. And it asks, what is the matrix product of these two matrices right here? So when we're doing this, you simply just multiply over. So we're going to create a new matrix. And since this is 3 rows right here, and this is going to be 3 columns, then the answer should have 3 rows and 3 columns as well. So you simply multiply over. So 2x times 1, 2x times 0, and 2x times negative 1. So that would be 2x, 0, and negative 2x. And then you do the same for 3x. 3x times 1, 3x times 0, and 3x times negative 1. So that would be 3x, 0, and negative 3x. And then same for 5x. 5x times 1, 5x times 0, and then 5x times negative 1. So that would be 5x, 0, and negative 5x. And looking here, the answer would be A. Okay, now we're going to go on to exponent and logarithmic rules. So for these, there's actually like a lot of concepts and like basically rules you need to know. So if you just search it up, I'm going to link something down below and it has everything on it. For exponents, for example, a to the x times a to the y is equal to a to the x plus y. And then there's a lot of other formulas for this. For log, it is actually like basically like the inverse of exponents. A of b equals c, then that means a to the c power is equal to b. Like it's basically how you find the exponents like the opposite way if it tells you something like that. These are pretty basic for the problems. I mean, they get kind of difficult if you don't know like the concepts of it. So make sure to know your exponent and log rules. Try to like memorize them, do practice problems with them, and then I think like it should be fine. But here are some example problems for those. Let's try a problem here, and this is practice test number 6, and this is question number 29. And it states that if a, b, and c are positive integers such that a to the b power is equal to m and c to the 2b is equal to n, then what is m times n? So this is basically saying what is a to the b times c to the 2b. So as we can see here, they both have an exponent of b. So we can take the b out, so that will be a, and then the c is left with c squared, and then we take the b out right here because when we distribute it, it will go into the a and then it will go into the c squared. And so the answer right here would be a. Now let's look at problem number 41. And it says that for positive real numbers x, y, and z, which of the following expressions is equivalent to this expression right here? And so we know that if it is to a 1/2 power, then that is going to be the square root. And if it is to the 3/4, then that means that is y cubed, and then the square root is not square root, but it is with a 4 right outside. And then for the last one, it would be z to the 5th power, and then right here it will be 8. So if you're trying to find something in common about all of them here, we can see that first, let's make all of these common denominators. So x to the 1/2, instead of saying x to the 1/2, let's make it x how much over 8? Well, that would be 4/8 because 4/8 is equal to 1/2. And then for y, instead of saying y to the 3/4 power, let's say y to the 6/8 power. And then z would just stay 5/8 because that was our common denominator. Now we have all of these over 8. And then that would be x to the 4th power, y to the 6th power, and then z to the 5th power. And then so the answer would be D. Okay, now moving on to polynomials. This is actually a really big section of the ACT. There's usually always a bunch of problems that either use polynomials, ask you to basically write a polynomial and then solve yourself, or a lot of things like that. So the things you need to know are, first of all, factoring polynomials. So the basic one is a plus b, like all of that squared, is equal to a squared plus 2ab plus b squared. This is like a must-know formula. And then also like a minus b squared is equal to a squared minus 2ab plus b squared. These are like just two formulas that you like actually absolutely need to know on the ACT. It makes your life so much easier than like having to do multiplication like that. So here are a few problems that use that formula. Practice test 6, number 22, it states that the length of a side of a square is represented as 3x minus 2 inches. Which of the following general expressions represents the area of the square in square inches? So we can draw a little diagram. So if this is a square and one side is 3x minus 2, then that means all of the other sides are 3x minus 2. And this is in inches. So it is asking you the area, well, that is side squared. So 3x minus 2 squared. And so how you're going to do this, remember a plus b squared is equal to a squared plus 2ab plus b squared. So a right here is 3x, and then b is 2. And then we know that a minus b squared is equal to a squared minus 2ab plus b squared. So in this case, it is 3x minus 2. So the a is 3x, so it's going to be 3x squared minus 2 times 3x times 2 let me erase this, plus b squared, and b is 2, so 2 squared. So 3x squared is 9x squared, and then 2 times 2 times 3 is 12x, and then plus 4. And so that is our expression right here. And this is in square inches. So our answer is going to be K. Question number 23 asks, which of the following is a polynomial factor of x squared minus 2x minus 24? So in this polynomial right here, it's asking us basically to factor this polynomial. And so for x squared, it is just 1x times 1x. And then for the right side, for 24, so what can multiply to have a product of 24 but have a difference of 2? So we know that it can be 4 times 6 is 24, and then 4 minus 6 is negative 2, which is right here. And so that is going to be our expression. So it is going to be x plus 4 times x minus 6. And if you want to check, you can always factor it out. So these are the two factors of that polynomial. So looking at our answer choices, the only one that is right is x plus 4. The other ones are x plus 6, x minus 4, 6 minus x. Those are all not it. So our answer is B. Another thing for polynomials is finding the solutions of a polynomial. So if they give you a polynomial and they're like, what are the solutions or what are the two factors of this polynomial, then you gotta know how to factor it. This is usually taught in algebra. So make sure to really pay attention during class when you're getting taught that, because that is a really important concept and different teachers teach it different ways. So like the example problems I'm about to do, they might not be like the way you got taught, but just make sure to use like the way you got taught or whatever is easiest for you. But make sure to know how to factor and find the solutions of polynomials. Question number 27 asks, what are all the solutions for x? If 3x squared minus 2x minus 21 is equal to 0. So how we find the solutions is a lot like the problem we just previously did. So first we must factor. So for this side, we know it is 1x times 3x. And then what can make a product of 21 but have a difference when combined with the 1 and 3 of 2? So let's just try 3 and 7. So 3 times 7 is 21. And then right here, 3 times 3 is 9. And then 1 times 7 is 7. So how do we make this so that it becomes negative 2 when those two are added together? Well, we can do negative 3, because when 3x times 3 is negative 9 plus 1 times 7, which is 7, then we make negative 2. So our factors are x minus 3 and then 3x plus 7. And this equals 0. So our solutions are either when x minus 3 is equal to 0 or 3x plus 7 is equal to 0. So either x is equal to 3, this is one solution, or 3s is equal to negative 7, x is equal to negative 7 over 3. These are our two solutions. So looking at our answer choices, we know it's not that one because it's not negative 3, and we can see that it will be D, negative 7 over 3 or x equals 3. Question number 54 from practice test 6 says that if x squared minus 45b squared is equal to 4xb, then what are the two solutions for x in terms of b? So this is another polynomial because we can see that there is two variables, but one of them is like x and the other is b, and it is asking you to find the two solutions for x. So x is our variable right here. But we can rewrite it so that it is going to be x squared minus 4xb minus 45b squared equals 0. And it is asking for the two solutions for x. So we're trying to solve for x right here. So let's factor in terms of x. Well, we know that it is going to be 1x times 1x. And then what has a product of 45 but has a difference of 4? Well, we have 5 times 9 is 45, but these two products have to be negative, so one of them has to be negative. So which one should it be negative? Well, the sum has to be negative 4. So we know that the only solution is if it is negative 9 and then 5. And remember, there is still a b squared right here, so we have to have 5b and then 9b instead of just 5 and 9. So that is what was a little bit different. So our factors would be x plus 5b and then x minus 9b is equal to 0. So x plus 5b equals 0 or x minus 9b equals 0. So x is either equal to negative 5b or x is equal to 9b. So the answer would be K, 9b or negative 5b. Question number 58 states that let x equals 2y plus 3z minus 5. What happens to the value of x if the value of y decreases by 1 and then the value of x increases by 2? So let's express this. So what is going to happen to x when the value of y decreases by 1? So instead of just being y, it will be y minus 1. And then the value of z increases by 2. So instead of just being z, it is going to be z plus 2. And then we carry over everything else. So let's factor this out. X is equal to 2y minus 2, and then 3z plus 6 minus 5. So notice that we have these two numbers that we don't have in the original equation. So let's put those together. So x is equal to 2y plus 3z minus 5 with this additional plus 4 right here. So everything else is the same, but this new expression has an additional 4 to it. So the value increases by 4 and the answer is K. Also from test 9, question number 17 states that in the standard xy coordinate plane, how many times does the graph of x plus 1 times x minus 2 times x plus 3 times x plus 4 intersect the x-axis? So this, we don't necessarily have to draw an xy coordinate plane as long as you know what this means. So all of these are the solutions for the graph. Since there are no exponents, so for example, it's not x plus 1 squared, then we know that there is only one value when x plus 1 is equal to 0. So if x plus 1 is equal to 0, which is where it hits the x-axis, since the y-coordinate will always be 0 then x has to be equal to negative 1. So if we draw the graph, then negative 1 right here will be a dot where it meets the axis. And then x minus 2, then that would be positive 2. And then x plus 3, so that would be negative 3. And then x plus 4, so it would be negative 4. And so here are the 4 dots where it intersects. So it would intersect with the graph. So it would intersect with the graph 4 times. Okay, and now we're going to move on to the last section of the polynomial section, and this is this is just one problem, but this is like the most important problem you need to know on the ACT. So usually you don't get taught this in class, but it is applying basically a lot of things you need to know from polynomials into one problem. And this problem is usually like on the ACT math section, and it is just different numbers, but this is like if they give you what a plus b is, and they give you what a squared plus b squared is, and they're asking you what ab is. You're not trying to find a or b, but rather the product of both numbers. And so here's the example problem and like how to solve it. This is a really common problem, but it is also pretty difficult if you don't know how to solve it. So once you know how to do it, it is basically the same for every other problem, just a change of numbers. So the problem is going to essentially ask you if you're given a plus b equals a number. So for here, a plus b is equal to 7, and then a squared plus b squared is equal to 37, then it is asking you to find a times b. So here you don't have to solve out for just a or just b, but you just have to find the product of these two numbers together. So we can use what we know for polynomials. Well, we know that a plus b squared is equal to a squared plus 2ab plus b squared. And since it already gives you a plus b, we know that a plus b is equal to 7 squared is equal to a squared plus b squared, which is we already have right here, is 37, plus 2ab. And now let's solve this. So 7 squared is equal to 49. This is equal to 37 plus 2ab. So 2ab is equal to 49 minus 37, which is 12. So ab will equal 6, and that is your answer. So it is this simple. We just have to remember this formula right here, and we can solve the problem. Okay, now going on to the very last section, which is volumes and areas. So here's a picture right here of basically all the volumes and areas you need to know for the ACT math section. It is usually pretty basic ones. The harder ones they usually give you, like sometimes they give you how to find the volume of a cylinder, even though you should know that. But the basic ones you need to know are obviously like how to find the area of a square. Triangle is base times height divided by 2. And then like circle is pi r squared, where r is the radius. And then finding the volumes. So like for the volume of a cube, it is side cubed. And then for a rectangular prism, it is the length times width times height and all that stuff. And then how to find the surface area of a rectangular prism and stuff like that. But the questions on the ACT math section are pretty basic when it comes to volumes and areas. So here are a few examples of those. This is problem number 4 from practice test 6. It says that what is the volume in cubic inches of a cube whose edge each measures 5 inches in length? So we can draw a cube. Remember, this is basically a square that is 3D. So each side of the cube, the lengths are all the same. And so if one edge is 5 inches, then all of the other sides will also be 5 inches. And so we know that the volume of a cube is equal to side cubed. So it would be 5 cubed. So that would be 5 times 5 times 5, which is equal to 125. So the answer would be J. Question 10 is a little bit tricky. It says that the figure below shows part of a circle whose circumference is 40. If arc of length 4 and length s continue to alternate around the entire circle so that there are 8 arcs of each length, what is the degree measure of each of the arcs of length s? So here we have a circle, and this is just part of the circle. So this is like, for example, let's say from like right here to right here. And it is saying that the arc lengths of 4 and then s continue to alternate. And it already tells you that our circumference is 40. So all around, this outside right here is going to be 40, and it is asking you what s is. And it says that there are 8 arcs of each length. So 8 times 4 plus 8 times s is equal to 40. Well, that is 8 times 4 plus s is equal to 40. So 4 plus s is equal to 5. Then that means s is equal to 1. So the arc length right here is 1. But it is asking you what the degree measure of each of the arc is. So basically, from the center, it is asking you what this degree is if this is 1 on the outside. Well, we know that in proportion it is 1 over 40 because it is 1 out of the 40 of the entire circle. But what exactly is this degree right here? Well, we know this is proportional to if the whole circle is 360 degrees, then what is the degree of this part right here that corresponds to the 1? Well, cross multiply. 40x is equal to 360. So x is equal to 360 divided by 40, which is 9. So the answer would be G, 9 degrees. Okay, let's look at our last problem. So it says a formula for the volume V of a right circular cylinder of V equals pi r squared h, where r is the radius and h is the height. If a tanker truck has a tank as shown below with a diameter of 3 meters and a length of 10 meters and is filled with water, then the weight in pounds of the water cargo is, and it is asking you what the weight is. And it gives you a little note that says 1 cubic meter of water weighs approximately 2,205 pounds. So right off the bat, we notice that it tells us the formula for the volume of a right circular cylinder, and it says that it is pi r squared h, where r is the radius and h is the height. So we know that 2 times the radius is the diameter, because right here it gives us that 3 is the diameter, and then the length is 10. And so this length is also the h, which is the height. So we know that this is the h, and this is the d, and then so if 3 is the d, then we also know that r is equal to 3 over 2, which is equal to 1.5. So now that we know that much, we have basically converted most of the stuff. So what is the total volume? Well, the total volume is pi r squared h, where r is 1.5 squared, and then h is 10. And solving this, we get approximately 70.69, and this is meters cubed. So if it is asking you the weight and it says 1 cubic meter is about 2,205 pounds, then our weight would be 70.69 times 2,205. And we get approximately around 155,862. And so this is between 125,000 and 175,000. So our answer is G. Okay guys, that is it for today's video. I hope you enjoyed and you took something away from it. I hope this helps you out on the ACT. I know it's ACT season and a lot of people are taking ACT because like the October one, December one, and all of that. So good luck to everyone who's taking the ACT, and I hope this video helped. Comment if you have any other problems you want me to work or any other sections you want me to go over. I'll be happy to do any of those. Make sure to like, subscribe, and turn on post notifications, and I'll see you in the next video.